the answer. The first question, many indicators are colored substances. So many indicators are colored substances which are obtained from the plants. The student extracted the colored substances.
Mr. Can we use mic or only chat?
No, you can. It's good you use a mic. I prefer that you use a mic during the class so that it saves the time. If you want to use a chat, you can use a chat or you can also use your mic. It's up to you.
Yes, Mr. So A, it's mortar, and B is stand, and C is filter funnel.
Filter funnel, good. So A is basically mortar, B is a tripod stand or stand, and C is a filter funnel. Then second part, student analyze the colored solution using a chromatography. Complete the diagram where the spot of a colored solution should be placed and the level of the solvent. So use screen annotation to answer the first part where we should place a spot of a colored solution. That's right. This is correct. So we should place on the origin. And the second, where should be the solvent level? So where we should place like the position where this is a solvent level. Once the chromatograph, this will be the solvent level once it rises. But beginning of the experiment where we should place the solvent level should always be below the origin. This is once it rises, yes, definitely it will rise to the level, but the diagram is there. So whenever the solvent level in the beginning of the experiment, it should be below the origin. So that's also correct. Then explain why pencil is used to draw the baseline on the chromatography paper. What is the reason why we use a pencil? Why not pen or ink?
Because ink will like flow.
Yeah, so we can say that because it can dissolve ink, or if we use a pencil, why? Because the pencil
Or Mr. It can lead to impurity.
Yeah, it will lead to impurity. That's also correct. You can mention ink will dissolve, that will give you mark. You can mention pencil contain graphite, which is insoluble, does not dissolve. That will give you a mark, or it may interfere with the result, or it may change the result. The next part, the student made two chromatograms. As you can see, two chromatograms are there. The only difference what student did, one chromatogram he dipped in hydrochloric acid. So one of the chromatogram, the solvent which was used is hydrochloric acid, and the other chromatogram, the solvent which he used, that is sodium hydroxide. Then determine the number of colored substances in a solution obtained from berries. How many colored substances are there?
2.
So yeah, that's right, because the number of the spots show us the number of the colored substances, number of the fractions present in the mixture. So because there are two spots, you don't bother about what are the colors. You have to check only the number of the spot, because the number of the spots give us how many substances are there in the mixture. So if we have two spots, it means it consists of two substances. If three spots, it means three different substances. Different. So the number of the spots gives an idea that there are two substances, and why the substances have different color. Even though, like example, if this is A, this one is A as well, B and B. The reason is because one, we are using an acid, so indicator have different color in acidic and alkaline mediums. Then the table gives the color of some indicators in acidic and alkaline. Use the data in the table and the result give a possible identity of one indicator in the berries. So using the result, can you identify? So this is an acidic condition, and here is an alkaline condition. What is the color of anthocyanin? It is red in acidic, and in alkaline it is blue. So you can see this spot, because this is an identical spot. So it means it was in acidic condition, it was red, and in alkaline condition it is blue. So which indicator? In acidic condition it is red, and alkaline condition it is blue. So that is anthocyanin. So that is why the possible indicator present is this one. Why not bromothymol blue? When I check bromothymol blue is yellow in acidic condition, but there is no yellow color. So that's why bromothymol blue is not there. If I check Congo red is blue and red. So in acidic condition, it is blue. Example, if this was Congo red, if this was a Congo red, it is blue in acidic, okay. But when we check in alkaline condition, the same spot should be red. But here the same spot is in green color. So it means this is not a Congo red. Then we check methyl purple. Methyl purple should be purple, but you don't see any spot in acidic condition. It should be purple, but there is no spot of purple color. That's why there is no methyl purple. So the indicator which is present, like the possible indicator, one of the possible indicator present is anthocyanin, which is red in acidic, and alkaline it is blue in color. The blank pages are there if you need to do extra work, anything calculation, or any part you want to do extra work, you can use the blank pages. A student investigated the temperature decrease when a sodium hydrogen carbonate react with hydrochloric acid. The student did 6 experiments. First, using a measuring cylinder, 25 cm cube of hydrochloric acid was poured into a conical flask. He measured the initial temperature. 1 gram of a sodium hydrogen carbonate was added, and at the same time, the stop clock was started. The acid and the sodium hydrogen carbonate mix in the conical flask, and using a thermometer, we record the final temperature after a minute. Conical flask was rinsed with a distilled water. Then experiment 1 was repeated using 2 gram of sodium hydrogen carbonate instead of 1, then 3 gram, then 5 gram, then 6 gram, and 7 gram. So basically what we did, amount of sodium carbonate, hydrogen carbonate used is changed for each experiment. Now use the thermometer diagram to complete the table and calculate the temperature decrease. So these are the values. Is it readable to everyone? So what we have to do, we have to complete the initial reading, initial temperature. Then we have to record the temperature after 1 minute. Then we have to record the temperature after 1 minute, and then the temperature decrease. So you can use a screen annotation to complete the columns. First, complete the first column, the initial temperature. Use the thermometer readings. What is the initial temperature for each experiment? 1 to 6. The first one is 29. That's correct. The second one is 29 as well. That's right. The third one is 22 as well. That's right. 22.5. That's correct. 23. Okay, 23. That's right. Look, whenever there is one more thing that is correct, all the values are correct. There is no mistake here. But normally, just a minute, uh, when we complete, there one more point I want to mention. Look, here one of the value, as you mentioned, one of the value was 22.5. So one of the value was 22.5, and rest we were writing 22. So whenever we complete a column, we should always use the same number of significant figures. So if I'm using 3 significant figure or 1 decimal place, so I should use same number of significant figure. So I should write as 22.0. Even though 22.0 is same as 22, but there is a way to, as being a science student, you should know how to write a column. So whenever you're completing a value, you should always use the same number of significant figure or same number of decimal places. Because one of the value I have to use 22.5. So I should write all of them in the same manner, that to one significant figure, 3 significant figure or 1 decimal place. So it will be 23, even though it is 23, but I will write as 23.0, so that all will have the same number of significant figures. Now complete the second column, which is temperature after 1 minute. So that is right, 19.5, 17, 14.5, 13.5, 14.0, and this also 14.0. And the last column is a temperature difference, temperature change. So how much is the temperature change? Here it is 22, and this one is 19.5. So what is the difference in the temperature? That's 2.5, correct? This one is 5, that's right. So even though it is 5, so we'll write as 5.0, that is 77.5. In each column, there should be equal number of significant figure. So 22.5 minus 13.5, so it will be 9.0. Because the difference is 9. Here also 9.0. And the last one is also 9.0. So that's right. So this is correct. 2.5, 2.55, 7.5, 9, 9, and 9. So this is a, and see, this is not difficult questions, and you will, once you complete this, you will score 4 marks. The next part, plot the results from experiment 1 to 6 on the grid. Draw 2 best fit straight lines through your points. The first straight line should start from, should be 3 points and must start from origin. And the second straight line, the last remaining 3 points and must be horizontal. Extend your line so that they meet each other. So this is a graph for us for when we use 1 gram, because if you see, this is a mass of sodium hydrogen carbonate. So mass of sodium hydrogen carbonate used was 1, 2, 3, 5, 6, and 7. So when we use 1, so when 1 gram was used, it was 2.5. So when 1 gram is used, it was 2.5. So this is 3. So each box is representing 0.2, so 2.4 and 2.5. Then when 2 gram is used, it was 5. So between 4 and 6. This is the second point. Where then it was, because the mass, we did not use all the mass. We use 1 gram, 2 gram, then 3, 5, 6, 7. So 1 was there, 2 was there, and then when it is 3, It is 7.5. So this one is 7. Between 6 and 8, 7, 7.2, 7.4, and 7.5. And then we use 5, 6, and 7. So 5, when it was 5, it is 9. When it is 6, it is 9. And when it is 7, it is also 9. The temperature change. The temperature decrease. Because the last column, as you can see, how much temperature change, decrease in temperature. So the last column we are using, which were 2.5, 5, 7.5. And we have to, according to question, we have to draw two straight lines, the best fit straight line. The first 3 points, we will draw one line by using the first 3 points from, and it should start from origin as I mentioned. So I should extend this line starting from the origin. So this is one line. And then the second line, as I mentioned, the last 3 points, there should be a horizontal line and they should meet at 1 point. So this is how we plot this graph. Now we have to use this graph. We have to use this graph to get the result. Then the second part, C1, from your graph, determine the temperature decrease and the mass of a sodium hydrogen carbonate where the two lines meet or intersect. And so what we have to do, we have this graph. We draw the best fit straight lines to include the maximum point on the line, the number of points above and below. And the question is calculate how much temperature has decreased and what mass of a sodium hydrogen carbonate when we draw, because it is a horizontal line, so definitely it will meet at 9. So this was about 9. And what about the mass of sodium hydrogen carbonate? Each box is representing 0.1. So 3.1, 2, 3, 4, 5, and 6. So this is 3.6. So this is the mass of sodium hydrogen carbonate, which is 3.6. Then the next one, why the temperature decrease become constant with a high mass of sodium hydrogen carbonate. In this experiment, what we are doing, we are mixing sodium hydrogen carbonate with acid. Like we have a conical flask. In a conical flask, we have sodium hydrogen carbonate, NaHCO3, and then we are adding acid. And every time, every experiment, we are increasing a mass of sodium hydrogen carbonate. First, we use 1 gram, then 2 grams, then 3 grams, then 5, 6, and 7. But when we use 5, 6, and 7, we find that the temperature is not changing. Like the maximum temperature or temperature change is constant. So what does it mean? It means there is no more reaction when we are using a high mass of sodium hydrogen carbonate. Or what else we can say? That we can say the acid is used up. Because sodium, when we are increasing amount of sodium hydrogen carbonate, there is an amount of HCl which will react with that. But once all of the HCl will be used up, the acid will be used up, so there will be no more reaction. If there is no reaction, there will be no more change in temperature. So why the temperature decrease become constant with a high mass of sodium hydrogen carbonate? The reason is because the acid used up or acid reacted completely. Next one, the investigation was repeated with dilute hydrochloric acid, half concentration, but same volume. Sketch on the grid the graph you expect to obtain and label that as line D. If you are using more volume but less concentrated acid, so it means the reaction, the rate of what we did, like example in the beginning, we use greater amount of acid, the more concentrated, like more particles of acid. but now we reduce the concentration, we make it half. So if the amount of acid is half, what will happen? The temperature change and the amount of sodium hydrogen carbonate which is reacting, that will also be half. Like example, the first experiment, when we plotted the graph for the first experiment, this was the first graph. Like this was the first graph for when we were using the acid. But now what we did in the question, they're saying we reduce the concentration of acid, we make it half concentration. So if we reduce the concentration of acid, what will happen? Amount of sodium hydrogen carbonate, like here, if 3.6 gram of sodium hydrogen carbonate was reacting, if amount of acid is half, so amount of sodium hydrogen carbonate which is needed to react, that will also decrease. So half the concentration means half amount is needed. So half of 3.6, that is about 1.8. So how much acid is needed? How much sodium hydrogen carbonate is needed? That will be about 1.8. So around 1.8, and the temperature will be around 4. So what will be the shape of the graph? The temperature decrease. So this will be the shape of the new graph, and we label that as D. Is it clear, this part? The next part suggests 2 changes that could be made to the apparatus, improve the accuracy of the result, and for each change explain why it will improve the accuracy of the result. Whenever you're checking, like you're measuring or you're using a certain volume, so what you can, you're using here a measuring cylinder. So what we can do, because if you are using a measuring cylinder is not accurate. So for this type of question, whenever they ask like improvement, you should always, the answer is actually given in the question. If you read the question, the second line here, using a measuring cylinder, we add hydrochloric acid. Measuring cylinder is not accurate. It is used to measure approximate volume. So what we should change, a measuring cylinder should be changed by using a pipette or a burette, which is more accurate. And then what we did, we placed them in a conical flask and we are measuring a temperature change. But what should be the best way? Because if a reaction involves releasing a heat energy or absorbing the heat energy, so we don't prefer to use conical flask, we should use a polystyrene cup. Why polystyrene cup? Because polystyrene is an insulating material. It does not allow the heat to transfer sideways or to the base. Because otherwise what happens when we are using a conical flask, if the reaction mixture might lose some of the energy to the surrounding or might absorb energy from the surrounding. So it is not suitable. So what is the best apparatus whenever there is a temperature change during a reaction? So we prefer to use polystyrene cup. So the 2 changes, what we should make to change to the apparatus, instead of using a measuring cylinder, we should use a pipette or a burette, which is more accurate. And the second, we can use a polystyrene cup, which is insulator, does not allow the heat to transfer. So here I can mention use pipette. And explanation that is more accurate. And second change, use the polystyrene cup, because polystyrene material does not allow to heat to escape or transfer. And the reason is that because it is insulator, does not allow or reduce the heat losses.